Dear all, welcome to World Federation of Engineering Organizations webinar organized by Young Engineers Future Leaders Committee. Today's webinar on climate action is the second event from our Engineering the Future series. We are bringing together outstanding senior professionals and bright young engineers to hear and learn from their experience. And at the second part of the webinar, we will have an interactive discussion. So all, please record your questions in the spreadsheet available in the chat box. Climate neutrality is a long-term goal which can be achieved only by the collaboration across continents. Hence, we are looking forward to reaching you all, WFEO young engineers from Americas, Europe, Africa, Arab region, and Asia Pacific, so we could work together on this. To start our webinar, we have Dr. Marlene Kanga, who is immediate past president of WFEO. Marlene is a chemical engineer and was national president of Engineers Australia. Dr. Kanga is a board member of Sydney Water Corporation, Air Services Australia, Standards Australia, and other boards involving innovations. She's also a director of IOMISCENT. Marlene, please.
Thank you very much, Milda, for that introduction and for having me here. It's a real pleasure to be here and to talk to young engineers about climate change, because this is your future. This is what it's all about for you. And I'm sure young engineers all around the world are very concerned about this issue. I'm going to cover three topics in my speech tonight. I'm going to talk a little bit about the World Federation of Engineering Organizations and our work relating to the environment. Secondly, I'll talk about climate change and COVID-19 and where there are some similarities and some differences as well. And thirdly, I'm going to talk about the work of the World Federation of Engineering Organizations in preparing young engineers with the skills to address climate change. So the World Federation of Engineering Organizations is a peak body for professional engineering organizations. So our members are the professional engineering institutions of the world. We were founded in 1968 and we have some 100 national members and 12 international and continental regional members representing 30 million engineers. And you see our map of members here right across the world. And I welcome all the participants from all these areas around the world, from every continent. Significantly, we are the co-chair of the major science and technology group at the United Nations. And we also work with many United Nations groups. We have a number of standing technical committees that focus on the sustainable development goals. Of course, we have young engineers, but we also have engineering and the environment, and we have the chair of this committee speaking here tonight, Davide Stronati. And we also have a committee on disaster risk management, natural disasters. And here are the UN agencies relating to the environment that the World Federation of Engineering Organization works closely with. A key objective of the Federation is to advance the UN Sustainable Development Goals through engineering, because these provide an integrated approach to balance the needs of people and the planet for economic development. But to achieve these goals through engineering, we need to have more engineers with the right skills to develop the engineering solutions that we need. And this has been recognized by the UN Secretary General, who sent us a message at one of our events in late 2018, where he said every one of the goals requires solutions rooted in science, technology, and engineering. And also UNESCO has recognized the role of engineers in engineering by declaring World Engineering Day each year on the 4th of March. And this is an opportunity to celebrate the work of engineers in engineering especially in addressing climate change. Now, climate change has had devastating impacts around the world. And here you see a picture of the fires in California and last month. But earlier this year in January, similar fires were burning across Australia, where I am based. So climate change is really affecting every country in the world. But climate change is also linked to COVID-19. For example, deforestation has resulted in wild animals increasingly going to populated areas in search of food, as we see here with the tigers in India. And the result is transmission of viruses like COVID-19 to humans. And rising temperatures can create favorable conditions for the spread of other diseases such as mosquito-borne diseases, malaria, and dengue fever. So there are some similarities with the global pandemic and with climate change. Pandemics and climate risks are similar in that they are physical shocks to our system, and they have created an array of social and economic impacts. Both are systemic in their direct manifestations, and their knock-on effects have propagated rapidly across an interconnected world. We are all in various levels of lockdown, irrespective of which country we're in. International travel is greatly restricted, and we're all wearing masks, hand washing, and social distancing. These have become a new normal in a few months. Both the global pandemic and climate change are non-stationary. We are now in a situation where past probabilities are shifting and cannot be used to predict the future. Both are non-linear. Their impacts are disproportionate and even catastrophic once certain thresholds are breached. For example, hospital beds and beds in intensive care units quickly reached their limits in many countries, something that was unprecedented and unthinkable just 12 months ago. Both climate change and the global pandemic are risk multipliers. They highlight and exacerbate untested vulnerabilities, as I mentioned, in healthcare systems and also in the economy. Millions of people have lost their jobs and are helpless as we wait for the vaccines to be developed. Both are regressive. They affect disproportionately the most vulnerable populations and subpopulations in the world. In fact, in many developed countries, it has been people of color who've been disproportionately affected, even in the medical profession. And neither can this be considered a black swan event, because these events have been predicted. And the only way we can address this for both climate change and pandemic is global coordination and cooperation, because these problems know no boundaries. There are no national boundaries. And we must come together for solution to these problems. And the same actions that mitigate environment risks also reduce the risk of pandemics. And in fact, it's a big wake-up call for us to consider climate change and the impacts that will soon be upon us. So we can reduce our demands on nature by optimizing consumption, using local supply chains for food, substituting animal proteins with plant foods, and decreasing pollution, deforestation, and increasing biodiversity. Addressing pandemics and climate change requires a fundamental shift. We need to think long-term and give up the short-term thinking in terms of healthcare systems, physical assets, infrastructure services. The global public health crisis that we are now facing is imminent, and so we are fighting for survival. Climate change is gradual. It's easy for politicians and decision makers to postpone the changes that are needed to mitigate the impacts. But these impacts will manifest themselves and will be cumulative and distributed. So the climate change is an accumulation risk that we are looking at. Governments are incurring tremendous costs as the ultimate source of funds in terms of the economic stimulus and in dealing with the pandemic is much greater than the cost of dealing with climate change. The speed of deployment and the depth of the crisis depends on the willingness of both government and the private sector to address policies and strategies for the long term. For example, it costs US $100 to reduce a ton of greenhouse gas emission, but it is costing us between 3,000 and 4,500 per ton to reduce greenhouse gas emissions, the reductions that have occurred, approximately 18%, as a result of the economic downturn. This is a huge cost. At August 20,000, 600,000 people were known to have died from COVID-19, a death rate of 14 per 100,000. By 2016, global temperatures are projected to rise and to raise global mortality rates to the same level, 14 deaths per 100,000. So climate change will be as deadly as COVID-19. It's just a longer time frame. And so we need to wake up today to start mitigating those impacts. And engineers are at the heart of the solutions to climate change. For example, bringing in affordable, renewable energy, a key sustainable development goal, as 1/6 of the world's population does not have access to a reliable source of energy. So engineers have developed innovations such as solar and wind power and will continue to develop new solutions. Engineering is needed to mitigate the impacts of climate change and for resilient infrastructure and to build back better. And you can see here a culturally appropriate method to build back better in Fiji after a cyclone with language with 2 local Fijian languages shown here in the instructions. And the World Federation of Engineering Organizations is doing its part with its model code of practice on the principles of climate change adaptation for engineers. And new technologies can also help us to accelerate the development and implementation of other solutions. For example, researchers have mapped out using geospatial tools where the Earth currently and could potentially support more forests that can absorb greenhouse gas emissions. So what is the role of the World Federation of Engineering Organizations? What, in fact, are we doing to address climate change? Well, we made a declaration on our commitment to addressing the Sustainable Development Goals on our 50th anniversary in March 2018. And we've developed a plan, the Engineering 2030 plan, to address the gap in engineering capacity and the quality of engineering professionals. This is a plan which is a partnership between universities, industry, government, and the members of the Federation. So we're working together with our committees, and we've also signed partnership agreements with the world's engineering educators, with the consulting engineers, with women engineers, and with research institutions involved in engineering. So we're working together and collaboratively to address key issues in terms of the quality of engineers and the supply of engineers. So we're looking at the global standards for engineering education and professional development, a key issue for young engineers. And we're looking at capacity building to ensure that the engineering education institutions are at the right standards. We're also looking at capacity building for the professional engineering institutions that manage the professional competency pathways once you have graduated, and supporting national and international registration of these qualifications and credentials. Because we need these projects to ensure that young engineers have the right skills to develop the solutions that we need to address climate change and are available where they are needed most. Because we have a great deficit of engineers in many parts of the world, especially in Africa. So here you can see the comparison of the numbers of engineers per 10,000 in the USA, UK, Australia, and Malaysia, around about 80 to 100. But in South Africa, it's less than 5. This is in 12 countries in South Africa. And indeed, 12 countries represented by this group, the deficit is more than 500,000 engineers. So we have a very long way to go. The second UNESCO engineering report, which is due for release in next month, makes the connection between engineering and achieving the Sustainable Development Goals, and in fact makes the recommendation that we need to work in partnership to develop the international engineering education benchmarks for sustainable development. And this is what WFEO has been doing, working with the International Engineering Alliance to review the standards, that is what you study, and to update these to meet current values and to also address current problems, in particular to advance the UN Sustainable Development Goals. So this is where we are working together to develop national engineering education systems that meet the global standards, and also building institutional capacity for accreditation bodies and professional engineering institutions. And the feedback today has been tremendous. One comment is that the framework that we have developed is truly transformative for engineering education. We're transforming engineering to meet the needs of the future, and especially to address the wicked problems that we are facing, especially climate change. And this is because the world needs more engineers with the right skills in the right places where they are most needed. We need engineers to be thoughtful, creative, innovative, to think critically about the impact of the work, and to act now. So young engineers can create the world we want, and we look forward to seeing the outcomes of your work in the years to come. Thank you.
Thank you very much, Marlene. If you have questions, you can already record them in the spreadsheet. And our second speaker is Davide Stronati, who is a global sustainability and climate change leader at Mott MacDonald.
Thank you, Milda. Thank you for the introduction, and thank you for the invitation to talk about climate change to the young engineers. I'm going to say maybe the message from me is not going to be dramatically different from what Marlene said. It was a very strong presentation from Marlene about what WFEO is doing and the importance on climate change. But effectively, as she said, I'm also the chair on the Committee on Engineering and Environment at WFEO, who is tasked to progress and to address climate change solutions in engineering. So I think that first of all, it's a bit embarrassing that somebody like me comes and talk about climate change to young engineers, because frankly speaking, I think that they are remarkably knowledgeable and extremely passionate about addressing climate change. And I'm saying this in my day-to-day basis, being the father of a young daughter who is aged 9 and being a leader in this engineering company named Mott MacDonald. I'm seeing that the young engineers, they join us because they want to make a difference. They really want to, address the current situation, which is of an emergency, because I think that we've been playing and fiddling a bit too long behind the scenes, and we haven't been serious enough about climate change. I think that there is still room for improvement, and to say in a very diplomatic way, on getting a much more collective and global action against climate change. But I also think that we are seeing signs of leadership, and not least the one coming from China to become carbon neutral or net zero. The devil is in the detail by 2060. This is potentially going to shift dramatically the geopolitical balance around climate change. I'm very hopeful that the British diplomacy will do a good job for COP26 next year in Glasgow to really, unify all our voices across the globe to address climate change. But as I was saying at the beginning, there's never been such a dramatic and exciting at the same time moment to be in engineering. I'm saying dramatic not just because of COVID, but fingers crossed, COVID will be a matter of the past in some months, years time. I'm referring to the climate change, because even if the world is going to achieve net zero by 2050, the climate is changing. The climate will be changing. And what we are trying to do is just to, limit the rise of the changing climate to 1.5 degrees. And that's the best case scenario we can hope for all of us. So this is bringing consequences. This is bringing real consequences that, as Marlene showed in her slides, we are already living them today. And there's no way out. We are going to live them even more in the future. So that's why it is dramatic, because we need to make a difference now for the long term. And but equally, I think as an engineer myself, wanted to make a difference and wanted to use science and technology and math and the human ingenuity to address problems. I think it is a remarkably exciting moment, because there are plenty of governments and plenty of companies around the world. They are taking climate change very seriously, whether because they want or whether because they must. So I'm afraid there is this aspect to be considered. Sooner or later, there will be a vast majority of organizations out there that will consider climate change as a fundamental topic and issue to be addressed. Now, if you're talking about mitigation, if you're talking about adaptation or resilience, if you're talking about the new technologies that Marlene was referring to, the so-called geoengineering or carbon dioxide removal, engineering is right there at the heart of these solutions. Whether we are talking about infrastructures, whether we are talking about cities, whether we are talking about communications, and COVID is a very good example that without the telecommunications, for example, I'm not sure how we would have coped. We would have all be much more isolated. We would be all much more stuck. And I think the social and economic consequences of something like COVID would be much more important. So engineering equipped us to be in the position we are to address these issues, which are unprecedented. In the same way, we need to consider climate change as something that is coming, something it is here already, not with the same dramatic impact of COVID, because it's been unexpected. If we think the world, how it changed overnight between February and March this year has been something that I guess we never lived in our lives. Nevertheless, even if climate change is not as dramatic in the sense of the sudden impact that we are living in, I'm pretty sure that lots of us are also able to say what extreme weather events brought in their livelihood, wherever they are based, whether they are in the UK or the United States or Australia or anywhere else on this planet. So I'm afraid again, just a matter of time. Climate change is coming indeed. So within WFEO, what we did, and we saw our role as an institutional role on sensibilizing and raising the bar of the climate emergency across the world. So what we did at the end of last year at COP25 in Madrid, we produced a climate emergency declaration. The climate emergency declaration was aimed primarily at raising the bar of the emergency aspect on climate change. Because as I said at the beginning, it is a matter of time, but not all governments across the world are in strong agreement, let's put it in this way to be mild, on the fact that climate change is present and action needs to be taken now. So we produced the climate emergency declaration, which has been signed by conspicuous amount of members. We are around 35 members, and you can read it in more details on the WFEO website. But on the top of the declaration of emergency, we wanted to give a bit of a roadmap on what we think are the 11 points which are important for each member organization to follow. And I'm pleased to say that there is an important space for the more balanced gender approach on climate change, because we need to harness all the ingenuity that all humans have on addressing climate change. So there is the mitigation aspects. There are the aspects on open sources as well. We need to share best practice. We need to share knowledge. We need to share what is working on addressing both mitigation and adaptation. And we are promising that from our perspective, we are going to do our very best as Committee on Engineering Climate Change to promote the role of engineering with all the different stakeholders. Of course, the United Nations agencies on the top of them, on the importance of engineering and engineers in addressing climate change. Because as Marlene said, the 17 goals are 17, and I don't believe that one is more important than the others. However, climate change, the number 13, does have a material impact on lots of others, does have a real material impact. And therefore, the best and the only way to address the SDG 13 on climate action, it is through engineering. And I'm really hopeful that the younger generations will take us to the position we want to be. Will take the leadership position, because the role that I see for somebody like myself is to be at your service, is to be at the service of the young engineers that they want to make a difference. So this is what I tend to do pretty much in the organization I work for, not McDonald's, but also in WFEO. My expectation is that we give you the platform to really suggest and provide input and feedback and really take ownership almost of this agenda on climate change. So on these notes, I would leave the floor to you for questions and for Milda to introduce the next speaker. Thank you.
Thank you very much, David. Our next speaker is Bert. He is Policy Director at European Roundtable for Industry, which is a forum for CEOs and chairs of large industrial companies of European origin. Bert coordinates ERT's views on sustainability issues and has been involved for over 10 years in European climate policy.
There we go. Thank you very much, Milda, for the introduction. We really very much appreciate your invitation. We are very honored that we can be around to present you some views a bit from a European angle on how we basically deal with climate action, not only with climate action, but also with a few other topics here back in Europe. And I'm also willing to further discuss those elements, of course, together with the audience, because there's quite a lot that is happening at the moment back in Europe. But first of all, let me say that we are actually living in very interesting times. It's a very fascinating world nowadays, because there are so many opportunities nowadays that basically arise. At the same time, the world is really changing very, very fast. So I would really like to highlight you for the next 10 minutes a bit what that really means in practice and what kind of impact that can really have on you and on our lives, and how we can actually contribute to make sure that an issue like climate change is really properly addressed. But maybe before I dive into the substance itself, let me say you 2 more words on ERT itself. So I'm working as a policy director at the European Roundtable for Industry. So as Milda was already saying, we are a forum of CEOs and chairmen of different industrial companies. All of them are very global companies. I'm pretty sure that many of the names that you see here sound quite familiar to you, but all of them are headquartered back in Europe. And basically those people, they come together twice a year, so their leadership comes together, and together we discuss and we agree upon different actions, different ideas that we want to put in practice, and also in order to put for Europe forward and in order to strengthen Europe's place also in the world. As you can imagine, of course, an issue like climate action is really on top of the agenda at the moment, also within the business community. As I was already saying in the beginning, we can actually see a number of quite important transitions that are happening at the moment, actually worldwide. But within Europe specifically, we call them the so-called twin transitions. So it's all about greening Europe, but it's also about digitalizing Europe. Greening Europe is actually quite a big agenda in Europe. So it goes about all the different topics, I think, that Marlene was already addressing in her speech. So it's about biodiversity, about making sure that we actually can make our economy much more circular. It's about addressing environmental hazards, but it's also a lot really about climate action. And there you may be aware that Europe has really the ambition to be leader, let's say global leader in the area of climate action. So we have set ourselves already a target, a 20% greenhouse gas reduction by 2020, by this year, which will be achieved, a 40% by 2030, and an 80 up to 95% greenhouse gas emissions reduction by 2050. And at the moment that we are discussing this, actually the ambition is to further increase these targets to at least 55% by 2030, and to become actually climate neutral by 2050, which would mean that you have a balance, so to say, between the emissions and the CO2 that is absorbed worldwide. So that's actually a kind of first wave, first mega trend, I would say, worldwide, but especially in Europe, it is really very strong in the policy agenda at the moment. The second wave, it's really about digitalization. And digitalization is really going to be key also for the climate, but I will come back to that. And what we can see there is that Europe is a little bit lagging behind, especially the US and Asia, in, for example, rolling out 5G, which is a communication protocol. So you can say that Europe is all below in the number of base stations, for example, that we have. We are only at 8. Countries like South Korea, the US, China are way ahead of us. So there is a need really also within Europe to speed up in this digital area, not only in 5G, but also in cloud development and artificial intelligence. And of course, if you want to speed up, you're going to need people also that have knowledge of these technologies and that are able really to implement these. And especially as Europe, it's a bit contradictory because actually the two world leaders in this area, Nokia and Ericsson, they're actually European companies. So we also encourage world leaders to take a bit more action in this area. But let me go back maybe to climate neutrality and to the climate agenda. So maybe an important message is that the companies, our member companies, really support climate neutrality by 2050. So there is some kind of consensus between European industry to really move towards this target of 2050. You may have seen also the recent declarations, even by oil majors like BP and Shell, that have completely committed to this target. So you can imagine that the challenge for them is also really huge because they have to transform their business from something which is more carbon intensive all the way to some kind of activity which is not polluting and not emitting CO2 anymore. So there too, the challenge and the opportunity at the same time is really tremendous. Of course, if you want to make that shift towards climate neutrality, there are a number of enablers, a number of issues that you need to address in order to make a very smooth transition. So there is a need for a carbon price. So it means basically that you put a cost on the pollution. You have to internalize your externalities. We are doing that already within Europe to a large extent, not completely, but to a large extent we already do. And we would actually also like the rest of the world to move ahead with carbon pricing so that it's not only our European products that actually have a kind of competitive disadvantage, so to say, because we have that system of carbon pricing. So there too, we pretty much push, and we are pretty much in favor also of other continents really taking action there, because we very much agree also with what the two other speakers have been saying. The need for action is really urgent there too. In addition to carbon pricing, we're going to need to invest much more in clean energy. Clean energy needs to be available, it needs to be affordable. For that too, we're going to need to invest in the right infrastructure for that infrastructure. Again, you can feel that there is a need for action. There is a need really to deploy new technologies also in that area. And then thirdly, we have to focus on the demand side. So we must make sure that there is a business case also for people to really buy low carbon products, because you can in the end make a low carbon product, but if everyone is still going to buy the carbon intensive product, there is something really wrong. So there too, we need the right triggers so that people are going to buy the right low carbon product. So that's also something to further think on. It's also another challenge that we actually see. And of course, and it actually underpins these three pillars, it's really the need for investment in clean technologies. It's about innovation, but it's also about starting up pilots, about building demonstration projects to really showcase and see what works, what does not work, before we really go to a much more massive rollout. So you can see that the agenda is really quite ambitious at the moment back here in Europe. So I've been talking about the green transition. I've been talking a bit about the digital transition, but I would actually like to bring in a third component, which is the skills element. And as we actually move ahead with the green transition, with this kind of digital transition, we're going to need people that actually have the right skills to enable this transition. So if you look, for example, at some of the estimates, we can see that here in Europe, there's going to be around 1 million new jobs by 2030 due to the low carbon economy alone. While at the moment, we actually already have a gap for digital profiles. So there's 1 million existing vacancies in Europe already for digital technology experts. And you can imagine, as digitalization, as the greening is going to continue, you're really going to need people with these right skills in order to fill those gaps that actually already exist at the moment in terms of profiles that we are able to find. But it's also important to see the connection between digital and green. Digital is an enabler of green. If at a certain moment we're going to switch to electric cars, for example, and maybe at a certain moment self-driving cars, we're going to need IT people, we're going to need the IT infrastructure to make sure that all these cars can really communicate with each other. So in that sense, digital is an important enabler of green. While green itself has also an impact on digital, because the IT sector will have to decarbonize as well. All these servers, all the electricity that they consume has to become green electricity. So there too, there's also a need for some technology upgrades. So my message is really like, look, all these things are really very, very strongly interconnected. And it's really moving forward very, very quickly here. So if we then look at what kind of skills are actually in need for the future, well, we did last year, we did a small survey amongst our members in order to identify a bit what kind of skills they would actually see as most needed in the future. And you can see there is quite a strong focus on leadership, social influence, analytical thinking, and innovation is very high. But the third component is actually also the active learning and really the learning modes. And that is something that you start seeing coming back more often and often, because the pace of change is so fast that we actually start looking more and more for people that know how they can actually acquire new skills, how they can actually learn new things. So it's really this kind of culture of lifelong learning, of permanently educating yourself, which is really becoming the thing or the skill, I would say, that is really very much needed nowadays. If we then look a little bit at the school curricula, and we also asked there a bit our members what they think in terms of gaps or points where schools could basically further improve. Well, the first focus was again on soft skills, but exactly that element of lifelong learning also coming back here, but also the connection between schools and industry or real life is also a very important element where there's some room for improvement. Like for example, boosting the system of apprenticeships as it already exists in some countries like Germany, Austria, Switzerland, could definitely be a kind of model also for other parts of Europe and even the world, I think. Then a third message is that it is not only about new skills that we are talking. I mean, issues like STEM, engineering, it's very, very, very crucial already at the moment as we are speaking right now. And also the systems that are in place at the moment, they need to be kept updated. They need to be kept up and running. So there too, the current skills, the current old hard skills are definitely still very important, but just have to be expanded now with this new skill set, which is required for the greening and for the digital. Maybe just to conclude, I would like to show you this graph. It's like, as human beings, we always tend to think in a very linear way. And to some extent, we expect that our future will be some kind of extrapolation, a linear extrapolation of where we are now and of our current progress that we make. But real change usually tends to go a little bit more in a kind of exponential way, where you may end up in a completely different place than what you had expected before. Hence also the importance, of course, of lifelong learning. So thank you very much for your attention. I'm of course very open also to take some questions. So back to you, Milda.
Thank you, Bert. It's great to have you. Now we are going to our young engineers. We have two speakers, and we will start with Sara Nyberg. Sara recently graduated in energy and environmental engineering from Lund University. Now she's working as a consultant at the company South Pole, with helping companies to reduce their greenhouse gas emissions. Apart from work, she has been involved in different environmental organizations since 10 years. And she is currently engaged in the Swedish Youth Climate Network Push Sweden. Through Push, she is active in YOUNGO, the youth constituency to the UNFCCC, and its working group on the technology mechanism. Sara?
Yeah, thank you very much for the introduction. I will share my screen now to show some slides. So I think you should be able to see it now. Yes. So I will talk about the youth involvement in the technology mechanism of the UNFCCC, and our aim, it's about speeding up the spread of climate technologies. So I will change the slide. So first a bit about who am I. There I went a bit too fast. I will explain a bit like what I'm doing, maybe a bit longer than would be usual, but it's try to give inspiration to other young people who hopefully listen to this webinar about what you can do, and you can be engaged in many ways. So first is a bit about my background. I studied environmental and energy engineering at the Lund University in Sweden. And I also did an exchange at ETH Zurich in Switzerland during my master's. Right now I'm working as consultant at the company South Pole, where you see our symbol is a penguin, as you see in the top picture. And I work with greenhouse gas accounting, so calculate the carbon emissions of different companies. And to also do other services to help companies to reduce their greenhouse gas emissions. In my free time, I engage in also another organization called Yes Europe, which is Young Leaders in Energy and Sustainability Europe. So yeah, a network to have exchange between students and young professionals in the energy sector. But my main engagement the last years has been in Push Sweden or Push Sverige, and in its international group. So through Push, I've been participating at the last 6 climate conferences. So you might know about the COP, the Conference of the Parties in the autumn, There are also climate conferences in the spring, so I've been to those 2017 to 19 as an observer for my organization. So we follow the climate conferences and the negotiations and communicate back to young people in Sweden what's happening there. So through these climate conferences, I've met other young people, and we kind of gather under the umbrella called YOUNGO, so the youth constituency to the UNFCCC. YOUNGO has a lot of different working groups, and one of those, so one which we actually created recently, is the technology mechanism working group. And I will come back to that very soon, what we do. But that's, that's what I've been doing. So actually, as I said, I will speak today about youth involvement in the development, transfer and implementation of climate technologies. But I'm also open to questions later if you want to know more about my work or my engagement in Yes Europe. So to the technology mechanism. So it was established by the COP in 2010. And the aim is to enhance the technology development and transfer to developing countries. And so why is technology so important for climate change? I know previous speakers have talked about that already a bit, but I mean, it is very important. However, I want to raise the point that we also need policy instruments and economic incentives, but it's still really good and important with climate technologies to be able to reach climate neutrality. And when I talk about technology, it's not many people think about renewable energy, and that's also a big interest to me. But it's also about energy efficiency, transportation, technologies for the industry and agriculture, and it's also about adaptation technologies, so such as early warning systems and flooding protection infrastructure. So more about, what is the technology mechanism? As you see in the picture, it's the UNFCCC, so the Conference of the Parties, which decides about it. And it has two bodies. So the one on the left you see is the Technology Executive Committee, and that's more the policy arm. So you see in the photos, that's a recent photo of the people who are part of the committee, and then of the meeting room, how it can look like during their meetings. And what tech does is that it analyzes issues and provides policy recommendations to support the countries to enhance climate technologies and develop and transfer those technologies. And it has different task forces on different topics. And that's the main thing about the tech. And then to the right, it's a CTCN. It's a Climate Technology Center and Network. And that has both an advisory board, which has a meeting 2 times per year. It has the network with a lot of members, and the center, which is like staff working there. So the aim of the CTCN is to provide technical assistance to developing countries. And it also creates access to information and knowledge on climate technologies. They have a lot of information on their website. They foster collaboration among different stakeholders in climate technology. And as I mentioned, they have this advisory board, which has a meeting 2 times per year. So that's about the technology mechanism. So next, I will say why we as young people engaged in the technology mechanism. So as you see, the slide is, I didn't find any good pictures, but I've shown a lot of pictures before. So the objectives to why we as in YOUNGO engage in the technology mechanism are to get more young people involved in the mechanism. Before, we haven't been so involved, but we see that we can bring like new ideas and contribute in a good way and come with new inputs. And we also want to share examples of youth involvement in climate technologies. And why is this important? So yeah, young people are very engaged and have a sense of urgency of climate action, especially the last 2 years, like with the Greta movement, more and more young people see that we have to do something. Like the grown-ups aren't doing enough, so we have to take it in our own hands. We have new perspectives, and we, as young people, develop innovative solutions. There are many young people active or starting startups with different cool climate technologies. And then what do we want to achieve? We want to involve more young people in climate technology projects, like on the ground, and like in order to accelerate climate action or to reach climate neutrality. Yes. So now to the, yeah, what do we concretely do then in the technology mechanism? So it's different things. One general thing in the middle up there, you see where I spoke at a side event at the SP50. So that's the climate conference last year in spring, where I share the views of YOUNGO. Then in the tech, as you see on the left side, we in YOUNGO participate in their meetings, which they have 2 times per year, as an observer currently, but we can give inputs to the work plan and other things. One thing that we raised was the importance of addressing behavioral change, so that it's, and also how technology can help us to change our behaviors on an individual level. We YOUNGO are also part of the tech task forces, so they're kind of working groups. And I'm part of the task force of enabling environment and capacity building. They also have a task force on support, implementation, and innovation, for example. And yeah, as part of the task forces, we give feedback to their policy papers, or if they send out a survey, we give inputs to those. And I also, down in the bottom left, Tech had a webinar to launch their recent publications. So there I was moderator, or YOUNGO was invited to be a moderator during that event. Yes, then some of our engagements in the CTCN or CTCN Advisory Board. So they meet 2 times per year. As you see up to the right, it's where I'm speaking and raising that we want to be more involved and also maybe become part of the board. We'll see how that goes. In the middle, you see a part of the CTCN progress report where we contributed with a chapter about youth. Down in the bottom, you see when we met the chair of the CTCN advisory board. And we plan to organize more webinars ahead and an internship and something called like a youth innovation lab this autumn. So yeah, so we're currently gathering examples of youth involvement in the development, transfer, and implementation of climate technologies. So if you're working on some concrete project, like please let me know. And yeah, as a preparation for next year, COP26, we hope to organize events and meet the people from the technology mechanism then, and to engage even more. So yeah, that was that from me. Thank you very much for listening. And just to have some final words. So yeah, I hope I could inspire you a bit. And yeah, I see it's really important for young engineers to engage in climate action. I know that during my studies, like I was maybe one of the most engaged people. The other ones thought, yeah, well, I will work with this later, but I see that in my free time, I engage in different organizations and I see it has given me a lot. And yeah, we are needed because latest 2050, according to IPCC, we need to get to net zero emissions. And yeah, it's not far away. And yeah, we can make a change and everyone can make something. And no matter where you are or in which topic you work or study, like we need climate action everywhere. So yeah, just get started. Thank you.
It's an excellent presentation. Thank you very much, Sara. And I'm sure that there are many young engineers who would like to reach and learn more about your work, because it's definitely worth, although it's sometimes difficult to spend your free time volunteering in different organizations, but the value which you add and take from that is enormous. So our next speaker is Vane Aminga. Vane holds a BSc in Mechanical Engineering and MSc in Sustainable Energy Systems from the University of Edinburgh. She is currently conducting multidisciplinary research on the linkages between low-carbon renewable energy development projects and conflict in East Africa at Stockholm International Peace Research Institute. She has extensively worked in disenfranchised communities of East Africa through Fly Sister Fly Foundation, which she founded in 2011. The foundation designs and implements economic and social justice empowerment programs for pastoralist women, including peace building and energy access initiatives.
Thank you so much for the introduction, and I'm really honored to be speaking today. After that very inspiring, listening to all these inspiring panelists today. And I am not going to preempt what has already been presented, and I think that's what happens when you're a last speaker. So I'm just going to briefly introduce myself, like just expand what you said, and then talk about the young engineering community in Africa and some of the challenges that they may be facing and how perhaps they can be supported for them to be able to participate in climate action activities as well. So as you say, I am a mechanical engineer. I'm from Kenya, and I started a social empowerment initiative for women and girls in 2011. It's called Fly Sister Fly Foundation. And this was something I was doing on the side while I was still studying my engineering degree. Initially, it started as a program to empower more women and girls to get into STEM courses. But with time, we got a lot of support from civil society and private institutions. And we started working on more work, including renewable energy, so distribution of solar-powered technological products such as radios and lamps. And that is how slowly I started to get interested in the climate debate from the Kenyan perspective and from the eyes of a rural person, the person that is dealing with the challenges firsthand. And so right after my degree in 2015, I applied for a master's degree because I realized that there was a challenge, bridging my technical background and getting to be able to work actively in climate-related issues, the way the employment scene is structured in Kenya. So I applied for a scholarship and I went to study in the UK. I did a master's in sustainable energy systems, and I was really focusing on the social issues of sustainability and low carbon development and renewable energy issues. And right after that, I got to come to Sweden to work on this project that is looking at the social and conflict sensitivity of renewable energy projects. So what this project is primarily looking at is, we know that renewable energy projects have been, they are being promoted at large as solutions for climate, the climate challenge, but at the same time, if these projects are not carried out properly, if these projects are not carried out with proper consultation, if these projects are not planned properly to ensure that everyone benefits, including the local person in the areas where the projects are sited, we have seen cases where they seem to exacerbate local they are exacerbating local issues in the area. So we have seen the case of, for example, the Lake Turkana wind farm in Kenya, which is in our study as well. It's the largest wind farm in Africa, and it is at 310 megawatts. So that is a large project that is being focused on, gotten a lot of international attention because of the planning and what that means for future energy, renewable energy projects of that scale in the continent. And at the same time, we have seen that local people in the area where the project is sited in northern Kenya, they are not connected to the power. Local people have had grievances over the access to land issues regarding, their previous livelihoods were not really considered in the project planning phase. So these are some of the issues we're looking at, trying to see how issues such as exclusion of locals from the project planning process, how these processes or the climate solutions, how they are they really 100% carbon neutral? We have seen cases where electronic waste from from climate solutions, batteries and all that, and solar panels. So there's a lot happening in this space, but there's still a lot of research that needs to be done, and also policy planning to ensure that perhaps there are some issues that need to be addressed to have a very comprehensive and 100% renewable energy transition without leaving some people behind. And these are cases we already saw with the fossil era, and we do not need to repeat that with the current transition. Yeah, that's kind of like a summary of what I'm doing. And apart from the research that I'm doing on low carbon development and conflict sensitivity, I've also been involved in research at SIPRI, my organization, looking at how institutions, intergovernmental institutions are responding, how they are framing and responding to climate-related security risks. So what that means is we're trying to see how the impacts of climate change and how they emerge, or how they shape human and state security indicators. So I would give an example. For example, we've seen in parts of Lake Chad, the Lake Chad Basin and in the Sahel, whereby because of the climatic issues, because of climate stresses, because of droughts, pastoralists, communities are now encroaching into farmlands, and this is causing conflicts with local farmers. And so we are trying to see, my research is, on that bit was to focus and see how intergovernmental institutions, so that's at the level of the African Union, and we has shaped this discourse and how they're trying to create solutions to such issues. And there's also work on energy security issues, because some of the energy solutions are, so we have large transboundary energy reservoirs, such as the Grand Renaissance Dam in Ethiopia, and that has some geopolitical implications. And if you do not factor in the impacts of climate change in the process of creating, in the process, currently they are discussing how the dam is going to be filled. I think they've started filling the dam. How the dam is filled and how the implications of filling the dam on downstream communities in Egypt, and the geopolitical implications of that. So when they are having these kinds of negotiations, they have to factor in the impacts of climate change and how that is going to impact these kinds of relations between countries, and other large cross-boundary energy projects as well, like trying to see that there is a need for the climate impacts have to be really, they're very serious. There is a sense of urgency, as my colleagues already presented. But I am happy to share some of the reports that I've been part of later on. But now I'll just talk about the experiences of being an African engineer and the challenges and the opportunities. The IEA, and some of these figures I'm gonna share, they have already been presented. So I'll do a quick one. The IEA has estimates that over 60% of the global emissions, the IEA estimates that the energy sector accounts for over 60% of the global emissions, which is a predominant cause of climate change, as we already know. But the African continent contributes less than 4% of that. But unfortunately, the energy sector in Africa is among it's the lowest in the world, where we have average energy consumption in most countries at less than 0.4 tons of oil equivalent per capita, against the world average of 2 tons of oil equivalent per capita. And this is firsthand for me. I know so many people who are still using the traditional oil lighting mechanisms, which are, as we know, they have health implications and they're very expensive for the local people who are already battling with poverty. And so the continent, for everyone else, we know that Africa, socioeconomic and political challenges, endemic poverty, weak governance structures, energy insecurity, demographic pressures, rapid urbanization, name it all. But the impacts of climate change, they are really an additional stress factor in this already very vulnerable region, and they have very strong implications on human and state security indicators. So the challenges are very interconnected, and this is not something new, it's not novel. We've read about it, we've heard about it in a lot of the presentations before and in our day-to-day work. But so what about the young engineer in Africa? What are they doing, or how are they contributing to this discussion or to bettering the climate discourse or climate action from the African point of view? Unfortunately, since I was a woman engineer in Kenya for 5 years, I know that, and also I was able to do a master's in the UK. I can clearly showcase some of the differences I could see. For example, the economic challenges and poor funding opportunities for African engineers, they really set us aside. So I had a lot of opportunities to apply for even small scale funding opportunities to be able to work, look into issues that I was interested in. But this is not something I ever heard about for 5 years that I was studying in Kenya. And so I believe that there's a need to bridge this. There's a need to have more funding opportunities for young engineers in developing countries in Africa, for them to be able to contribute to not just climate research, but the UN Sustainable Development Goals. We have seen with the current COVID-19, we've seen that they say that necessity is the mother of invention. When the entire world was locked down and there was no opportunity for countries for us to buy from China, because a lot of the things we buy in Africa, even a razor blade, it's made in China. We have seen a lot of innovation. We have seen tremendous opportunities for young people to be supported, to create masks, for young people to create ventilators. And this shows that the engineers in Africa they have the brains, they are well taught, they are very skilled. They just need this proper support. So, and I believe that the COVID-19 has opened the world to see. I was also surprised. I remember at the beginning of the year when the pandemic was just starting, we were all really worried. We're like, what is going to happen? But now, as it is, I mean, it may be too early to speak, but there has been some amazing innovations from the continent and how it has handled the pandemic, which we can learn from. And the next challenge is obsolete curriculum, which was already mentioned by colleagues before, but my mechanical engineering curriculum I was able to compare, because as soon as I got to Edinburgh, I had to go to the mechanical labs and compare. And we were still really in the 70s. I'd say, like, some of the things we are doing, they're not aligned with the current issues. And if we are able to have that, you know, the engineer from Kenya, Nigeria, you know, Zimbabwe, be able to compete in the world and be able to address these issues. There's a need for, it doesn't have to be a complete overhaul of the curriculum, just improvement and fill the gaps and bring in new technology and, you know, and have well-capacitated engineers that can be able to address these issues on the global scene. And then obviously the issue of gender unbalanced gender dynamics in the engineering world. We already know that that's a fight that is happening everywhere, but in the African classrooms, that is worse. I was in a class of 6 women. It was in a class of over 100 students, but we were just 6 women, and we kept dropping off until the end. So it's very sad. And the more I do climate research, I know that women are at the forefront of, you know, fighting, facing the challenges. When we talk about energy issues, it's women, especially in the developing world. It's women who have to spend hours in the bushes trying to collect firewood. It's women who have to use a lot of potentially economic time trying to find ways that they can feed their families. And hence, we need more women engineers. We need more women engineers who know these challenges firsthand. And there is a lot of, I mean, I'm happy. I've been part of many women in engineering spaces. A lot is happening, but we need to do more. We need to push more, have more women in this space. And I look forward to such a time. And finally, and I'm a victim of this in a way, is brain drain, where engineering professionals tend to change industry. So a lot of my classmates ended up working in the Big 4 consultancy firms because the money was better. Since we have poor industry, university industry partnerships to ensure that students get jobs as soon as they're done with school. Many have not had jobs since we finished school in 2015. People ended up going into different lines, and so we lost a lot of technical people, a lot of engineers, and that happens a lot in many countries. And I have talked to people from other countries as well. I mean, this is not just in Africa; it's also happening elsewhere. So the brain drain, or having people move to economically stable countries. I mean, yeah, I am in Sweden now, but I'm still working on African issues. But I know many of us who would, you know, you have to weigh between being home to develop homegrown solutions for the continent, or fending for your family. You know, you have to choose the struggle. So those, among other issues, are some of the challenges that are basically facing the African engineer. And even when we're looking at the Climate for the Future movement, so since I'm in Sweden and Greta Thunberg is from here, I can see how the discussion is vibrant. I can see how young people I've been to one of the strikes, and it was very, very young children, very, very young children in the streets, really on the forefront of these discussions. But this is yet to pick up in the continent where we are facing the impact as we speak. It's not the future, it's today. It's happening today. We've seen cyclones, tropical cyclones that have never happened. They're happening. We are seeing droughts that have never happened in years. We are seeing locusts that are, have food security implications. To conclude, so what would I propose? I mean, all the issues I've highlighted above, they need to be addressed. Stakeholders have to coordinate. Government policymakers, they need to streamline collaborations with private sector, engineering companies. It's long overdue. So that, and also streamline industry, university collaboration, research, and all this. We cannot work in silos. We want to work together and ensure that at least by 2030, everyone is living a life of dignity, and not that a few people are able to, you know, I don't know, I was saying some people are supposed to go and live abroad, somewhere on the moon or somewhere. So those with money will leave the planet burning and go live in another world. So I don't know. Yeah, and then finally there is securing funding for green projects with climate benefits. I've seen this firsthand. A lot of my friends have started small EPC companies in Kenya, Nigeria, elsewhere. But it's a mountainous task for them to get financing mechanisms or funds for them to be able to develop small solar plants, for them to develop small hydro projects. But while this is happening, when these very motivated engineers are trying to work in this space and contribute to a net zero climate future, other governments are still pushing a lot of money into, you know, fossil fuel. So in Kenya, we have been having this coal plant, which has been, it has a lot of environmental implications. So it's very saddening to see that we even thinking about that when we have the robust resources, the sun is there, the wind is there, but still some policies are still very retrogressive. So I will finish there. I'm sorry for going out beyond my time. Thank you so much.
Thank you very much, Vane. It's so great to hear different perspectives from Australia, from Europe, now from Africa. And it's great that we have that opportunity to connect young engineers globally. And Africa has a great potential, so it's very interesting to hear the hands-on experience and insights from your side. And to conclude, we have Firas Diab, who is the chair of WFEO Young Engineers Future Leaders Committee. So he will give a concluding remarks, and then we'll open Q&A session. So you still have time to record all your questions, and we're really looking forward for that. So Firas, you can start.
Thank you, Milda. First of all, I would like to thank everyone of the speakers who gave us the opportunity to participate today in this important webinar for the Young Engineers Future Leaders Committee in the WFEO. I would like to thank Dr. Marlene. I guess it's 12:30 in Australia AM, and she's still with us. I'm always thankful for Marlene's support for the Committee of Young Engineers. She has done so far a lot of achievements, and she has give us a lot of support. I'm taking this opportunity to thank her. Also, I would like to thank our esteemed guest, Mr. Bert from the Roundtable of Industrialists, and also our colleague, David, the young engineers, Sara and Vane, and also I'm also thankful for your participation. You know, I just want to conclude, but I would like to say that the global climate change is one of the greatest environmental threats facing the world. And you know that the human activities such as the burning of fossil and deforestation over the past 150 years, they have led to huge emissions. Now, saying this, I'm trying to say that climate change is a defining challenge of our times. And I do believe that young engineers have a key role to play in reporting and in mitigation. This webinar came today as part of the sessions that we're doing for the under the theme Engineering the Future, in order to look at sustainable development goals. And today we're looking into the sustainable development goal number 13. I would like also to say that we need to amplify our voice on climate action, and we need to push the word, and we need to raise a flag and rise up and amplify our voices as young engineers to make the world a better place to live. I'm really, as a chair of the Young Engineers Future Leaders Committee, I'm really concerned how do the response of climate crisis is developing, and how the eyes of the world are watching to see what action may be taken. So I guess it's time at some point to quit business as usual and to transform as our economies to allow us to live in a world we want, where we are safe from climate impacts. I will leave it to have like a Q&A and to check for the questions that we are receiving from the engineers and for people who attended this webinar. I do believe that at some point we need to take this this radical change. We cannot sit and wait things to change. For example, we cannot imagine that the issue of the global heating is continuing and unchecked, and we are experiencing crazy impacts. We need, young engineers need to raise the voice again, need to have this work to be done during events or during their national organizations worldwide. I would like to say that we have to change course, and I will leave it till here, and I would like to check for the questions and answers from the people or the engineers who attended this this webinar today. And I would express again my deepest thanks for all the speakers, and we'll definitely be meeting again in future events and future webinars under this theme. Milda, thank you. If you would like to go for the question and answers, it's yours. I'm not sure if Milda is with us here. Probably she's facing some like technical issues. I will check the Google Doc and let's see what questions. We have a question from Shah Ji from Pakistan. He's asking, does 5G technology also contribute to climate change risk? I mean negative impact, because some people believe that's a signal ray. I'm not sure who would like to attend this to attend to this question.
I think I'm the only one who mentioned 5G, so I think I should take it also. It's not really my area. Yeah. So I think that, of course, the digital industry itself is of course also an emitter, and they also consume massive amounts of energy. So there is definitely some need too for decarbonization, which includes also 5G. Of course, you have a very big debate also about the health impact of 5G, which is also here in Europe a big debate, where you actually have people that really lit the antennas, so they burn them down and so on, because they are really concerned about the potential health impacts of 5G. So there too, well, if you look at some scientific evidence, the health impact would be, well, negligible. People say that 5G is safe and sound, but again, I'm not a big expert. But it's a debate, of course, that is ongoing. But notwithstanding that, of course, IT sector is also ready to further decarbonize. That goes without saying.
Thank you. Another question here: is nuclear power plant safe? Philippines is trying to reopen a nuclear power plant.
Well, I can also take that one. So it better be safe, right? But if you then look at what happened in Chernobyl and Fukushima, we can see it's not always safe. And I think that any technology, any application always comes with a risk. There's nothing that is without a risk, and that goes for nuclear, that also goes for other solutions. That said, I think it's also a kind of societal debate that you need to have to see to what extent you are really willing to accept that risk. And there you can really see that countries take various different positions. My country, Belgium, is going to phase out nuclear by 2025. Also, nuclear is very important in our energy mix. Germany has already made that decision. But at the same point, you can see that other countries like the UK, maybe even Poland, but I have a little doubt, are still investing in nuclear because they think it's for them the most efficient way to basically decarbonize. That said, if you look a little bit at economics of the energy mix, and that's at least what some people say, you can actually see that nuclear energy is losing out compared to other alternatives like renewables. So nuclear is not that much a safety issue anymore. It's much more about the economics, which would actually discourage people from further investing in nuclear. But there are different studies on that one too. Also, the nuclear world is evolving. We are no longer talking about big, massive plants anymore, but it can also be smaller plants that offer different opportunities that may be used in a different way. And of course, there the cost-benefit calculation can be slightly different.
Thanks a lot, Bert. Thank you.
May I add some points as well? I wanted to say, so every technology has positives and negatives, and as engineers, I think we need to balance this out and in a realistic manner. So there is risk, of course, in the safety risks in nuclear technology, but there's also risks in not doing anything about climate change, which could be worse in the long term. So these need to be balanced. And that while there are many countries going for wind energy and solar energy, it's sometimes not possible in countries which have low land areas and high populations, such as Japan and Korea. So they've got very big demand for electricity, and because of that large population, but small land area. So there are other technologies that are being looked at. For example, hydrogen is being looked at in Australia. There's a big push in Australia for green hydrogen, which is to be produced by electrolysis, where the electricity is generated from renewable sources. And Australia, of course, has lots of sun and lots of land. So we can produce that renewable energy and, if you like, concentrate it into hydrogen and then ship it across to these countries. So there are new and innovative ways emerging because there is also, a fear about not just the nuclear risk of nuclear in terms of an explosion, like the Fukushima disaster, but also how do you deal with the waste? So the waste problem is one that will go on for thousands of years and needs to be dealt with. So you're creating a different kind of environmental problem and a different kind of environmental risk. But there are countries like India that are looking at thorium, for example, rather than the traditional uranium, and also methods to reuse the waste so that it reduces the nuclear waste problem. So to recycle the waste back into nuclear plants. So engineers are very ingenious and very clever, and they're coming up with many solutions. So things never stand still, and people are always thinking of new ways to innovate and to bring these solutions to us, to our population. So I think we shouldn't be fearful. We should take these problems as a challenge and look for solutions.
Thank you, Marlene. Here's another question.
Can I also say something?
Yeah, sure. Go ahead.
Thank you. Yeah, I mean, nuclear can be discussed in it's a big topic, can be discussed a lot. But just to give some, just from my perspective, okay, yeah, nuclear power plants are low carbon. So I guess for climate, it's much better than fossil power plants. But still, they take a very long time to build. So if some countries are considering to do something for climate now and think about nuclear power plants, they take 10, 20, if even 30, many years to construct. but we don't have that much time. I mean, we have to be net zero emissions in 2050, and like according, like we should like halve the global emissions every 10 years, preferably. So in 10 years from now, in 2030, we should have halved the global emissions. And so time is running out, and we don't have, like, nuclear power plants is also good, but it's not the only solution. Because compared to renewable energy sources such as wind and solar power, they go much, much faster to build. So that's why I'm a little bit like questioning the opportunities with the nuclear power, because we don't have the time for them to be built. And it's also like uranium is also a limited resource. There is not endless of uranium, and the extraction of it is very dirty and affecting many people locally who live there. So yeah, renewable electricity such as solar, wind, and hydropower, at least small scale, I mean, they faster to build and more democratic as well. It's not as much like money going to big pockets of big companies, but it's, you can apply it more locally. So yeah, and those are some of my inputs to this topic.
Thank you, Sara. Here's another question. What specific actionable tasks can early career engineers take within their workplace, their voluntary organizations, and wider community and public? I guess, Marlene, you can have a say on this question.
Can you repeat that again? Sorry, I was looking at the chat.
Yeah, it's like, what specific actionable tasks can early career engineers take within their workplace or voluntary organization or wider community and public?
Yes, thank you very much, Firas, for that question. That's a great question. And I think I'm so pleased to see the young engineers here on today's event, today's webinar. And this is a great example of how you can be an advocate as well as develop your skills, because by exercising your leadership skills here tonight and in your other voluntary work, you're learning a great deal, and you're putting yourself out there in your community, in your workplaces. I think young people need to engage more with the community. As engineers, we're not very good at selling what engineers do, and importantly, the impact of engineering. I think we need to be more thoughtful and more critical about what engineering is about, and be therefore more vocal about it. We need to be out there and engage with policymakers, because far too often those making the decisions in government and at the highest levels are not, don't have a scientific background. They're not scientists, they're not engineers. So we need to be able to communicate complex technical issues in simple language that people can get. We've got to have that narrative and put that message across and be seen and be heard as much as possible. We need to be there more and more, you know, and we can't afford not to be, because these issues, we are the only ones really who can produce the solution. Scientists will dream up the theory, but engineers will make it happen. We are the ones that will make it happen, and we've got to show how we can make it happen. We've got to talk about it, and we've got to get out there, and we've got to engage with our employers as well. So I think that there's a big job for young engineers, for you to go out there, because I think what you have to say, people will listen to you, because you are our future. And this is very relevant to you as well. It's the rest of your life. I'm not going to be around for that much longer, but you are, and you are going to see these horrific impacts that I talked about. And you are in a position to do something about it. You must feel empowered for that.
Firas, can I ask something?
Yes.
So it's a very interesting discussion, and I think it's relevant to many of young engineers and professionals. And also it's very interesting to hear Marlene's perspective, and also what industry and large companies, their perspective. So it was very good to see that from Bert's presentation that companies are keen that young professionals continue with lifelong learning. And can you please, Bert, also give more examples of what type of lifelong learning is good to have, what voluntary activities are required?
Is that for me, Milda?
It was for Bert from European Roundtable for Industry.
Yes, I can definitely say a few words on that. So I think it's also quite specific to the occupation that in the end you're going to take. And what I can see also back in our member companies is that they really quite much start looking at what people's skills actually are already at the moment, and how they can people actually take along according to a certain trajectory. So at least within our member companies, which actually all happen to be quite big industrial multinational companies, they actually offer that kind of training course, and also to individuals in terms of what do you have now, where do you want to end up, and so that kind of training is actually available. And you can also see that there is a kind of shift also in the learning environment within companies. So rather than just offering a kind of one course for everyone, you really start customizing and really individualizing the training trajectory, really to be in order to be really very efficient and effective. So there is a big shift, I would say, also on the side of the companies right there. But lifelong learning, it's really going to be a kind of mentality. It applies to the young engineers, but it also applies to me, it applies to Marlene, it applies to really to all of us, just to be open, to stay curious, to stay interested in things, and really to keep on talking to people, to keep on acquiring new knowledge, and really try to identify those challenges and come up with solutions for those, and take action and leadership also for your own trajectory in terms of identifying the skills that you need in order to fill or to reach the ambition that you basically set for yourself. Don't wait for anyone else to come and tell you. So that's also very key. It's a leadership role that I also try to highlight in my presentation.
Thank you.
I might also add that the review that we are doing to the engineering education's global standards now emphasizes lifelong learning as a key requirement, because this is the only way. We don't know where new technology is going to go. It's developing so quickly. There are new areas emerging, new disciplines emerging very, very quickly. So young engineers will be given the skills to learn how to learn, to find the information, to absorb it, and to apply it. And this is going to become increasingly important. And the other big change that we've made is the importance of so-called soft skills, which in fact are more important than the hard skills, the hardcore science and mathematics in some areas, which include, the soft skills include leadership, and the ability to communicate to different levels, different stakeholders, and also in people who might be even geographically dispersed, as we are seeing now in the COVID-19 environment. So these are all the new areas that we've brought in and will be incorporated in engineering courses going forward. And so in a decade, it'll take a decade to flow through. You'll see young engineers coming out with a very different mindset, we hope.
To the same extent, you can also see that there are a number of real clear shortages, I would say, also on the European job market, for example. So when you look to industry, there is really a big lack of people that are specialized in big data, artificial intelligence. So that are a little bit the buzzwords that float around quite a lot. So especially for IT professionals, the industry keeps on repeating that we need more people with that kind of background. But when we focus on that, we also get a call from the more traditional manufacturers that say, hey, we also still need the engineers because we have huge challenges. As I was saying, we want to move to climate neutrality, but we need people that can think of this kind of new technologies that can really start implementing those. So we also need those profiles, definitely. So that's also very important, I think, to keep in mind. But the exercise on what kind of green profiles that we would need and what it actually means in practice, that is actually an exercise, I think, that back in Europe we still have to make. Really to quantify that gap between where do we actually see industry and the business going and what profiles are needed, and there's a supply meet demand. It's a bit the exercise that was done for the IT industry. That exercise at the moment is a little bit missing, I think. So there is also some more work to do there, I think.
Can I add something? Yeah, I also
Yes.
see that, like, from my own workplace, like, so I work with greenhouse gas accounting, like work in Excel basically, but we see that, like, I mean, our company is growing a lot and we want to employ many more people, and I see there's a gap. It's like we want to have experienced people, like more senior people with some experience. But I have many of my friends who are just recently graduated who are interested and want to work with this. But the company wants to have some people who are more experienced. So there's like a gap there. And also, like, there's not actually, like, there's nothing, like, there are some courses at university which are relevant for the work I'm doing, but it's also like a bit of a lack. I think that the university would need to teach more about, like, how to calculate like a carbon footprint, for example. So I see there is also a gap because there are so many who want to work more in climate change. I know many who maybe want to change career now that they see that the climate is changing and they maybe have a job which is not really contributing to tackle climate change. So I mean, I see there are many people who want to work with climate change topics, but then we also find it really hard to recruit the right people with the right skills and background and experience. And also to add to the previous question about, like, what tasks can young engineers do or take, like with workplace and organization level. So at the workplace, I would say just, like, I mean, try to, like, start at the office, local office, or how can you make an initiative to, like, reduce the energy consumption or buy organic coffee or organic bananas or something there. But it's also good to, like, build up and try to reach the higher levels in the company. Can maybe your whole company sets so-called science-based targets? There's something called the Science-Based Targets Initiative. Like, can you try to push for that your company should reduce your emissions in line with the climate science? Or can you push your company, even if it doesn't work with climate-related topic, but all companies should, in the end, like, in some years, everyone has to reduce emissions. So it's, I mean, the earlier that, like, your company or your organization starts to reduce their own emissions, the better. So that's one option. And also regarding if you want to be involved in an organization or an NGO in your free time, I mean, that's great, because if we go together, we're much stronger together. So even if you're working with something, you can in your free time engage in a climate or environmental related organization and do some action on local level or more international level. And yeah, I mean, this is not only for engineers, but in general. But just from an engineering perspective, what I see is important is that we have learn how to solve problems. I mean, engineering is a lot about, like, problem solving and so on. That kind of what mindset I learned during my education, at least. So I think that's very valuable, that we have to be aware about that. We as young engineers, we are trained to solve problems, and climate change is a very big problem. So I think it's a big challenge, but also exciting, and it is possible to do something. So we just have to, get our brains together and solve the problem.
Thank you, Sara. Thank you. You know, one last question. We have it from our colleague in the committee, Brooke from Ethiopia, from the Ethiopian Association of Civil Engineers. He's asking about what do you think is the reason that we haven't seen reforestation projects on a large scale or on a global scale? Marlene, what do you think? Marlene, you're on mute.
Muted. Sorry, I was on mute. Yeah, I think this again is an economic problem as well. So I did show a map of where it's possible to have reforestation, but I think the problem of deforestation is related to the economy and to the access for energy. So it comes back to providing access to distributed, low-cost renewable energy, which Sara talked about. And I think that this is an area where we can actually make a big difference in very small nations, in the small island developing states, in remote parts, geographically remote parts of the world. This is where we can make a real difference. And using solar energy or wind energy will really transform the need for say rural people to go out and hunt for firewood and contribute to the deforestation. So many of these problems are interlinked, and the solutions are interlinked as well. We cannot just make one blanket policy that will affect that will just solve the problem. And it also needs to be culturally appropriate to the local conditions. Conditions in Africa, very different to conditions in Asia and so on.
Thank you, Marlene. I guess that's all what we have for today's webinar. These are all of the questions. I would like to thank you again for your participation, and I'm sure we'll be talking very soon on different issues. Thank you for the time of today, and I would like also to thank Milda for moderating this webinar, and many thanks for the attendees from all over the world. Looking forward to see you again in future webinars. Thank you, Mr. Bert, Dr. Marlene, Vane, and Sara, and Milda. Thank you very much.
Thank you too.
Thank you.
Have a nice day. Nice night, Marlene.
Thank you. A great session.
Bye, everyone.